Oftentimes during the pen test, we would discover that the brute force attack that we need to perform, maybe let's say that's on the login page or any other page, we might not be able to send the number of requests per second that we want to exhaust the server, or maybe sometimes the server would start blocking our request, and then we are not able to proceed in certain cases. So there are some certain challenges when we are doing this brute force attack, especially in this modern architecture where we have the load balancer, we have application firewalls, and so on, right? Uh, Today we're going to talk about what are the limitations that we have in the existing tool set, and what are the improvements that we can use to perform more focused and more relevant brute force attacks. So this is what you're saying is the TLS or TCP handshake. Uh, the handshake is typically the host would first send a request to the server with the sync message. The server will send back the sync and acknowledgement, and then the host will acknowledge the server's acknowledgement. And that's when the connection is complete, or connection is open between the host and the server. Then the host would send a request to the server with whatever the request payload that it needs to. The server would respond to the request, and then the host will close the connection with the connection close, or either server after sending the response it will close the connection. And then if the host wants to send any additional information there, they will have to open up a uh, new connection, and that's very time consuming and cumbersome process. So imagine if you need to send like a 10 million request as part of your brute force attack to the given web application. How many connection do you have to open, and then you have to getting closed, and oftentimes server will block, like if it receives more than 50 connections and stuff like that. So this is very essential, and this is the limitation that we have with the connection close. The second option is connection keep alive. So we have seen, I think, few weeks ago, a demo of a tool called Skip Fish. I'll link that into our description below. But the Skip Fish tool, what it does is it opens up the connection and it sends the request, right? And the server would send the response back. It sends again request response, and it will close the connection when all the requests are sent or the response are received. So this is also no pipelining. So the connection will kept alive as long as there is a request and response to be waited. But this is still not, I guess, efficient way to send like a 10 million requests to the server if you want to exhaust or we want to do the brute force attack. So the new method that we are going to see in this video, or I'm going to show you the demo of, is the pipelining. So how this typically works is the client will send the request only without waiting the response from the server. Suppose you want to send, let's say, 1,000 requests per second. So client will, when the connection is open, client will keep on sending the request, 1,000 requests, and then when the server will give a chance to server to respond when all of these requests are sent, and then it will close the connection. Now here there are several benefits. One, we are getting higher chances of brute forcing or throttling the remotes, or executing successfully executing our payload on the server, because server does not expect this many requests would come at the same time, or per second. And the second thing is the memory consumption is going to be much lower than like opening up the multiple connection for performing 10 million request brute force attack. So this is what the pipelining is. And how we're going to achieve this is using the Turbo Intruder. So this is a new tool, or I wouldn't say it's a new tool, but this is a tool which one can use, or definitely, like if you are a pen tester in the security industry, definitely it should be in your arsenal. So you should be using this tool to perform this kind of attack. Now it is fast, and absolutely faster than the Burp Intruder, and more efficient. Of course, you need to know a little bit of Python, and that's why we started like a Python series last week. I'm gonna show you why learning Python is very much required in this industry, and if you want to be succeed in the security professional role. So you can customize your payload, you can customize the script. So that's all possible if you know the Python and if you can understand the code. I'll also walk you through the code, how it works. but just make sure you do follow the Python series. You can also launch like a multi-day attack. So if you want to like launch the attack and keep it running for multi-day, for suppose like 1 billion requests, that's possible. It is also possible to run from CLI. You do not have to have a GUI based client. You can run it without that as well. And the source code is on this location. I've also linked into the description, so be sure to check it out. The good thing is it is available in the Burp extension store. So if you want to run it, you do not need to install Python or do any extra work. As long as you have Burp, you can download and install it. So let's take a look at the intruder first, and then I can show you some other features of it. So first off, let's say you open up the Burp store. Here you will see the Turbo Intruder. You can see the ratings. It's 4.5 star, which is pretty much good. And it was last updated 19 February, which is very recent. And some of the options, like some of the features that we already discussed. So to use it, it's simply highlight the area you want to inject over, then right click send to Turbo Intruder. This will open up a window containing Python snippet, which you can customize before launching the attack. So let's do that. I'm gonna close the existing one. Um, so this is on the demo test fire side. I'm gonna go to the engagement tools, sorry, extension, and go to the send to Turbo. Okay, I forgot to actually, let me close this one. I need to highlight which so okay, let's say if you want to brute force the password, right? Okay, go here, send to. So if you notice here, there is a percentage %s. So this is where the payload will be entered, like placed instead of the string. Now these are various ready-made Python scripts which you can use. So if we start with this one, basic, right? So in the basic one, this is the default. Now what it does is, I'm not sure if I can zoom in but hopefully it's visible now. Or let me actually copy this and paste it in the notepad so you can see it. And font, okay, much better. Okay, so first off, this function, what it does is it queue the request. So we are creating a request engine, and the endpoint is our demo.testfire. How many concurrent connection do we want? Let's say we start with the one connection. And how do we request we want to send per connection? Let's say we want to do one request. And right now, let's start with the pipeline false. So I saw you two diagram, one with pipeline, one without pipelining. So first we're gonna start with the without pipelining, right? And here, what are we doing? This is the payload. So it's gonna read from this list and upload, replace this in terms of where the payload we have marked in the request. So it's gonna pick up one word. This is a for loop. Is as any other programming language, it's gonna pick up one word by one and strip any white spaces, right? And then put place in terms of the in place of the wherever the placeholder we have. And this is to handle the response. So it will only. So again, this is a good benefit. Let's say you're gonna capture a 1 billion response, right? If you're doing that sort of attack, then you do not want to capture 1 billion response. That's just too much memory consumption. So you want to customize or make it optimized so you are only capturing the response which is really worth it. So here there are some of the options you can filter based on request status. So here we are only capturing the response which is not 404. Then you can also do based on the word count, length, or the response. So this is what it is. I need to do before we launch this is I need to replace the word list with the one which I have. So I have it in the following location. Let me replace it. All right. Okay. This looks good now. Let's go back, paste here, and here is the attack. So let's start that. And as you can see, our request per second is 6. And we have 37 connection. So that means we had uh, 63 connections open and closed. This is request per second, and queue is 100. So what our goal is to increase this request per second so we can put more load on the web server, or probably getting more chances for our attack to succeed. So let me hold this back to the configuration, and let's increase from 1 to 50. Okay, now let's attack again. Now as you can see, the request per second is 18, which is almost like 200% better than what it was before. And good thing is we are also not getting any failures. So that indicates we can still increase this, we can optimize it as much as we can. So let me do 200 and let's see how it works. Okay, so we are still getting like 18 requests per second. So not much of an improvement. 18, 19. Let's hold it. Let's bring it back to 100 and let's improve the connection to maybe 10 connections. And let's see the difference here. Okay, there you go. We are now seeing a much more improvement. So as you can see here, we are getting 180 requests per second, which is of course 10 times better than what we had before. And now we can have multiple connections and multiple requests sent out. But this is still not good. Uh, Now let's see the difference when we enable the pipelining. There you go. This is, I don't know, like this is 4, 5, 800, 8,000 times better than what we had before, right? The request per second here is 1900. The previously we were getting around 100, 200, 150. I guess that was the max thing. But as soon as you enable the pipelining, and that's the power of pipelining, right? So you send as many requests as you want, as you can, without waiting for the server to send back the response. And most of the modern browser does support this feature, so this shouldn't be any concern for you to run that. So this is how, of course, you can be you have to produce your own word list to perform, but there are so many word lists out there. I just produced this one. It has nothing, just letter A, like 15,000 times. That's what I have. But yeah, you can also uh, use your own word list. Here you can see there are different types of attack, whatever you want to do. Like this is just for the debugging. If the connection is the whole server is not working. Um, these are also like learning. So suppose if you want this script or the intruder to learn that it's getting some sort of let's say every time it's getting in the response as unauthorized user, then it can learn that, and then it can also tune the future request in a such a way that will only capture the response which is not, which is relevant, and it will discard the remaining things. So it also has like sort of like an artificial intelligence thing in there. The next one that I like a lot is this one, a race condition. So let me show you how this typically works for you. So this part is same, which we had previously seen. This one. So the gate argument blocks the final byte of each request until open gate is invoked. So here what we are doing is we are opening or sending the request only, the last byte of request only after the entire queue of 100 requests for 30 connection is ready. That means like probably like 3000 requests, right? So we are making sure 3000 requests are ready to send out to the server, but we are not sending a request by request. What we are doing is we are queuing every request, and we are tagging it with the race one. You can apply your own uh, on your on tag. That doesn't matter. But here it's applying this tag. Now wait until every race one tagged request is ready, then send the final byte of each request. This method is non-blocking, just like queue. So then engine will open the gate for race one and then complete. So it's gonna send out all the request and then add all the response here. So if you want to create like a race condition, so just imagine in the previous example, what we were doing is we were sending like 1,000 requests per second, but also receiving the 1,000 requests response per second. Here, what we are doing is, for example, we are queuing everything for 2,000 requests in the queue, and then we are sending all the requests at once. So you have like 5 connection or 10 connection. You are queuing 15,000 requests, and you are sending all those 15,000 requests all at once, like relatively same time, which is hitting the server and probably breaking down the server. That is what it is doing. So if let me, yeah, so this one, if we attack this one, right? So here, of course, we have the pipeline turned off, and that's why its request per second is 30, because that's the concurrent connection that we would allow. But then we also have to open the pipeline here. But here you would see like this is not increasing or decreasing because we are sending all the requests at once. We are not so, and it says completed, right? So we are not just keep on doing the attack. We are gathering all the 30 requests and we are sending it. Of course, you can modify concurrent connection, this, and then you can, what you should also supposed to do is you can add engine.start. Oops. So, okay, this is actually, I'll put it here before it completes, right? Okay, and here. Oh, yeah, we only have like, it has to match the number of connection, otherwise it's not gonna work. So there you go. So we are sending this now 100 requests at a time, right? So this is how you pretty much do the, and why this is important. That's very interesting thing. So let's see this one. First of all, password brute force, and now the turbo intruder will be better than using the burp intruder. Suppose you're getting a website, and after trying out like brute forcing, your IP gets locked out. You're getting this message: if your password is invalid, please enter correct username or password. And in burp intruder, let's say you are configured for 10,000 requests, so there is no way for you to filter out whether the attack succeeded or not, unless you're just looking at, like, the response message of the like the body. The burp intruder will tell you, okay, the response is 404 versus 200 or 302 redirect, or whatever it is, and if you're filtering based on that, there is no way for you to know. Now, turbo intruder you can actually configure. So if let's say you hit the valid password, so you will not, your IP will still be locked out, but you will not get this message. So you can still continue brute forcing for the password even if your IP is locked out. So that is a excellent benefit of using the turbo intruder. So you can filter out that response. The next thing is the race condition that we talked about. Suppose you're going for shopping, and then you have a, of course, there is a coupon code which you can apply to an e-commerce website. The coupon is only one time use. But suppose you are using this rest condition, like this little script that we used. Let's go back here. So suppose you are queuing a request, 100 requests for with the same coupon code, and you send all the requests, 100 requests at one time. Then server would have to, like, there is no way for server to validate versus invalidate one, because there is no way server could go back, update the database, and then validate the next request. It's gonna allow, most likely it will allow all the 100 requests, and that way you will have, like, the same coupon code applied twice, thrice, whatever number of requests that you sent, and ultimately the discount you will get. So this is the similar use cases, like, I talked about like business logic as well. You can use this tool for such bypass. Uh, so that's what I wanted to, and this way you will also see like what's the importance of learning Python, because if you want to write or customize the script, you have to know the Python, and not just like the syntax, but also like how to execute Python and how to optimize it. So everything. So hopefully we will cover that in the future videos. But I wanted to show you guys this tool. Hopefully you like it. If you like it, please hit the thumbs up button. Comment below what other videos you would like me to cover. Any questions you may have, any suggestions you have. Thank you so much for your time. Please subscribe to the channel, and yeah, don't forget to follow me on Facebook. Thank you. Bye.